You are losing easy marks on your Cambridge IGCSE computer science exam because of one fundamental misunderstanding about clock speed. In the next few minutes, we're completely stripping away the fluff to show you the exact zero-nonsense strategy to stop hemorrhaging those marks and actually secure your grade. Let's dive right into the trap that catches thousands of students every single year.
So take a look at this phrase. Clock speed is how fast the CPU is. It sounds completely right, doesn't it? It's a classic, painful mistake. You've probably heard a classmate say it, or let's be honest, you might have even written it yourself in a past paper, walked out of the exam hall and thought, yep, totally nailed that one.
But here's the brutal reality. That answer gets you a massive, glaring 0. Absolutely nothing. Why? Because isolated memorization completely shatters against Cambridge's rigorous mark scheme. The examiners are not looking for you to just parrot back some oversimplified generic label. You know, students often actually understand the basic theory, but their ordinary revision totally fails them on exam day. And it happens because examiners don't want those short, punchy generic labels. They're explicitly testing your ability to explain a process and actually apply it to a given context. When you just memorize isolated facts without knowing what digital problem is being solved, or what data is involved, or what the real-world consequence is, well, your knowledge just crumbles under the pressure of a real applied exam question.
Now, in just a moment, I'm going to reveal the exact examiner clue that completely flips your answer from a 0 to top band. But first, we've got to build the framework that makes that specific clue blindingly obvious. Because without a rock-solid structure to lean on, you're literally just going to default back to those short, generic sentences that cost you the exam.
Okay, so enter the examiner-approved framework. This is your reliable, foolproof memory structure for clock speed and performance. It boils down to 4 distinct prompts. 1. What is it? 2. How does it work? 3. Where is it actually used? And 4. Why is it better or worse than an alternative in that specific situation? If you can answer these 4 distinct questions out loud, moving logically from the core concept to the technical evidence, all the way to the scientific reasoning, boom, your knowledge is truly exam ready. You aren't just memorizing anymore, you are engineering a top band response.
So let's actually see this framework in action. Cambridge absolutely loves to test theory inside a practical context, like, say, an embedded system running inside a factory robot. Now, look at the stark contrast here. The flawed answer just says, a higher clock speed makes the robot faster. It's vague, it's generic, and yep, it earns a 0. But look at the top band answer on the right. Higher clock speed allows the robot's embedded system to execute more instructions per second, responding instantly to sensor data. See the difference? It's huge. The top band answer actively anchors the specific processing concept, which is executing more instructions per second, directly to the context, which is the robot's sensor data. It spells out exactly how the process works and exactly where it's being used. All right, let's put you to the test. I want you to pause and predict for a second. Listen to this student's answer and pinpoint exactly why the examiner is reaching for their red pen. The scenario is a school network, right? And the student wrote, the school network upgraded its processor clock speed to store more student data. Can you spot the error? Did you catch it? The student totally confused processing speed with storage capacity. And honestly, the theoretical foundations often crumble right here. Students constantly lose easy marks by confusing nearby concepts. They'll mix up memory and storage, or validation and verification, or, like in our example, logic processing with actual data storage. A faster clock speed processes instructions faster. It absolutely does not give the school network a larger hard drive to hold more student files. Smart, dense revision has to train you to compare these concepts, not just look at them in a vacuum. So the main takeaway here is that to fix a flawed answer, you have got to avoid these classic wrong turns. Examiners tell us year after year that marks are thrown away because of vague wording, skipping sequential process steps, or just naming a device without ever explaining what it does. But the absolute biggest offense? Ignoring the context. If the exam question is about a school network, or a robotics factory, or a banking app, and your answer doesn't mention students, robots, or financial transactions, you are literally leaving marks on the table. And that brings us to the missing examiner clue I promised you earlier. It's called contextual anchoring. Examiner-style performance depends entirely on this one concept.
It's the practice of connecting your technical explanation directly to the specific, gritty details of the scenario they give you. Generic responses that completely ignore the real-world transfer, they almost never get full marks. You have to prove that you understand exactly why the clock speed matters for this specific system, not just in some imaginary textbook vacuum.
Knowing this strategy is great, but let's lock that knowledge in for exam day. Because to make sure you don't panic and fall right back into the trap of writing generic answers under the stress of the actual exam, you need a disciplined, layered approach to your revision.
This timeline is exactly how you do it. A bulletproof study session moves through 3 passes. Pass 1, secure your definitions and your key contrasts. Pass 2, rehearse those worked explanations. Literally speaking your 4-step framework out loud. And then, pass 3, test your exam adaptability by radically changing the scenario. Force yourself to explain clock speed for a smartphone, and then for a database, and then for a secure communication protocol. This sequence takes you from just recognizing the words to deep understanding and finally to rock-solid exam application.
So, you now have the exact framework to score top marks on clock speed, and you clearly see the critical importance of contextual anchoring. But you still face a massive risk. If your exam is right around the corner, you simply don't have time to randomly guess which specific scenarios and concepts to prioritize for the rest of your syllabus. How on earth do you map all of this out effectively when the clock is ticking down to 0? To solve this exact problem and make sure you aren't wasting hours studying the wrong concepts, you need to seamlessly transition into our next explainer. Watching the last 7 days revision map is your mandatory next step to guarantee you are prioritizing the absolute highest yield topics for your Cambridge 0478 exam. Do not leave your final week to chance. Are you going to walk into that exam hall relying on generic 0-mark labels? Or are you going to engineer top-band answers? The choice is entirely yours, but your time is running out. Subscribe to our YouTube channel, Ace the Exams, at actheexams_IGCSC to excel in your Cambridge examinations.